Okay, so this is a particular example that says that construct a natural cubic spline through the points 1, 2, 2, 3 and 3, 5. So there are basically 3 points and its respective y points, function points, and here in this side I have written these 3 conditions, and 4th condition is unknown based depending upon the question type. So first of all I will construct the x points. X points are 1, 2 and 3. So 1, 2 and 3, and y points are 2, 3 and 5. Okay, so these are the 2 points, and first of all I would write what is Sg of x, general polynomial. Okay, so how many splines do we have? We have only 2 splines. One spline is between this, that is S0, these 2 points, and the second spline is between this. Let me change this so that you can understand. Okay, here is S0 and here is S1. So we have only 2 splines here. Okay, so Sj of x is journal is Aj plus Bj x minus xj plus Cj x minus xj square plus dj x minus xj cube. Now this point is x0. x0 is 1 and x1 is 2 and x2 is 3. So this is y0, this is y1 and this is y2. This is x0, this is x1, this is x2, and this is y0, this is y1 and this is y2. So if for j equals to 0, this spline is equal to j is 0, 1, 2 and minus 1. So how many points there are? There are 3 points, then 3 minus 1 is 2. 1, 2 and 3. So there are only 2 splines, 0 and 1. So if j is equal to 0, then S0 for j equals to 0, S0 of x is equal to A0 plus B0 x minus x0 plus C0 x minus x0 square plus D0 x minus x0 cube. Okay, now replace this x0 here and here and here. So x0 is 1, x minus 1, x minus 1 and x minus 1. Okay, for j equals to 0, 1. For j equals to 1, S1 is equal to, because we have to consider this spline. So S1 of x is equal to A1 plus B1 x minus x1 plus C1 x minus x1 square plus D1 x minus x1 cube. Now I would replace this value of x1, that is 2. So here you can replace what is 2. So these are 2 points. I would say this let be an equation A and this let be an equation B. Okay, now we apply the first condition. The first condition is between the 2 consecutive points of x and their splines. And how many equations are required? Because there are 8 unknowns, that is A0, B0, C0 and D0, and A1, B1, C1 and D1. A0, B0, C0, D0, 4 unknowns, and also A1, B1, C1, D1. So there are basically 8 unknowns. 8 unknowns means you have to find out 8 cross 8 matrix. You have to construct 8 cross 8 matrix or 8 equations. Okay. So for condition number 1 is, I would select for j equals to 0. J equals to 0, S0 at x0, here I am applying, is equal to f of x0. If I would replace the value of x0, that will be 1. S0 of 1 is equal to f of 1. That is basically y naught. And that value is 2. So S0 of 1, if I would replace this this 1 in this equation A, then S0 of 1 becomes A0 plus B0, 1 minus 1 is 0, C0 1 minus 1 square is 0, D0 1 minus 1 cube is 0. So S naught of x, S naught of 1 becomes A naught is equal to 2. So let this be an equation 1. The conditions Sj at xj plus 1 is equal to f of j xj plus 1. For j equals to 0, this condition will be S naught of x1 is equal to f of x1, that is equal to y1. And S naught of x1 is S naught, x1 point is 2, S naught of 2 is equal to y1 point is 3. S naught of 2 is, if I would replace this S naught instead of x, I would replace in this equation A as 2, then it means 2 minus 1 is 1. B naught into 2 minus 1 is 1, C naught 2 minus 1 square is 1, and D naught 2 minus 1 cube is 1. Then this equation will become A naught plus B naught, because these are 1, C naught plus D naught is equal to 3. So let this be an equation 2. Similarly, for j equals to 1, you can apply here. That will be S1 of x1. Condition number 1 equals to f of x1, that is equal to y1. So S1 and x1 point is 2. So if I would, and y1 point is 3. Okay, if I would apply this in equation B S1 of 2 instead of x, I would write it as 2. Then this will become 2 minus 2 is 0, 2 minus 2 is 0, and 2 minus 2 is 0. So we will be left with only A1 is equal to 3. So that makes it equation 3. And also, for j equals to 1, this condition Sj at xj plus 1, that means S1 at x2, j plus 1 is 2, is equal to f of x2. F of x2 is y2 and y2 is 5. So S1 of x2, x2 point is here given as 3 and y2 point is 5. So if I would replace this in equation B x as 3, then 3 minus 2 is 1, 3 minus 2 1 square, 3 minus 2 1 cube. Then this equation will become, equation B will become A1 plus B1 plus C1 plus D1 equals to 5. So this, by first condition we get the 4 equations. We need 8 equations. Okay, so I would write these equations as in here in. Okay, now for condition 2, I need the first derivative. Now the first derivative of S naught of this is S naught dash of x is equal to A naught is 0, B naught is 1, and 2c naught x minus 1 plus 3d naught x minus 1 square. And also S1 of this, S1 dash of x is equal to A1 is 0 plus B1. B1 is simple, plus 2c1 x minus 2 plus 3d1 x minus 2 square. So these both are, we will say this is an equation C and we will say this is an equation D. We can use here in for condition 2. For j equals to 0, S naught dash at x1 is equal to S1 dash at x1. Point is same, only splines are changing, and we cannot use j equals to 1 because S1 dash is equal to S2 dash. We don't have any S2, so only for j equals to 0 it is valid. X1 point is 2. Now I can compare here. As this left hand side can be extracted from this, if I would replace here 2 in equation C, then this point will become B naught plus 2c naught, 2 minus 1 and 2 minus 1. So the coefficient will be 1. 3d naught is equal to S1 dash of 2. Now if I would replace this in equation B at the value of 2, then I would get 2 minus 2 is 0, 2 minus 2 is 0, and I am only left with this B1. So if I would shift this, all the coefficients and unknowns in one side, minus B1 equals to 0, that I will get equation number 5. Only this, if I would proceed further for j equals to 1, then it means that S1 dash of x2 is equal to S2 2 dash of x2, and I don't have any s2, so that is not valid for j equals to 1. Okay, now for condition 3, I need the second derivative. Okay, for this, if I would take one more derivative, then I could get the second derivative, and that means s naught double dash of x. Further derivative of this, b naught has derivative 0, 2c naught plus 6d naught x minus 1. So I would say this as equation E, and if I would take its derivative, second derivative, then I would get its s1 double dash of x is equal to 2c1 plus 6d1 x minus 2. This is equation F. Now I would use these two equations A and F for condition number 3. Okay, for j equals to 0, naught double dash of x1 is equal to s1 double dash at x1. X1 point is 2, so I would replace it as 2, and similarly I would replace it as 2. So s naught double dash, that means in equation E, if I would replace x as 2, then it becomes 2c naught plus 6d naught, 2 minus 1 is 1, is equal to s1 double dash can be extracted if I would replace this in equation F. I would replace x as 2, then 2 minus 2 is 0, this term vanishes, and this term vanishes, and we are left with 2c1. So if I would shift here, that makes it 2c naught plus 6d naught minus 2c1 equals to 0. So that means equation number 6. I would write these equation 5 and 6 in this corner. Equation 5 is b naught plus 2c naught plus 3d naught minus b1 equals to 0, and 2c naught plus 6d naught minus 2c1 equals to 0. The fourth condition is unknown here, depending upon what is mentioned in the question. Construct a natural cubic. Now the word natural means natural or free boundary conditions. That says that the first spline at the first point, that means s naught, let me do this here. Fourth condition, first line is s naught, and its second derivative at first point is equal to 0, and also last spline here is s1, double derivative at last point here is x2 is equal to 0, s naught double dash x naught here is 1 is equal to 0, and s1 double dash at x2 is 3 is equal to 0. Now s naught double dash means in this equation E, if I would replace x as 1, then this becomes 1 minus 1 is 0, 60 naught, and I would left with 2c naught equals to 0. That is equation 7. And s1 double dash at 3, that means in equation F, if I would replace x as 3, then it becomes 2c1 plus 61, 3 minus 2 is 1 is equal to 0. That will be equation 8. So I will write these equations here. 2c0 is equal to 0 and 2c1 plus 6d1 equals to 0, and then I would now construct the matrix system out of that. The unknowns are a naught, b naught, c naught, d naught, a1, b1, c1 and d1 is equal to the constants. Equation 1 has the constant 2, equation 2 has the constant 3, equation 3 has the constant 3, equation 4 has the constant 5, and equation this has the constant 0, 0, 0, 0, 7 equation, 8 equation. So this is the constant vector. Now I would go towards the matrix, coefficient matrix. So this is first equation, that means a naught has the coefficient 1 and a b naught has the coefficient 0, c naught has the coefficient 0, d naught has the coefficient 0, a1, a1, b1, c1 and d1. This is equation number 1. A naught has the coefficient 1, b naught has the coefficient 1, c naught has the coefficient 1 and d naught has the coefficient 1. A1, b1, c1, d1 has the coefficient 0 is equal to 3. Okay, done. Third equation, only A1 has the coefficient 1 and the rest of those other has the coefficient 0 is equal to 3. This A1, B1, C1, D1. A1, B1, C1, D1. So 1, 1, 1 coefficients A0, B0, C0 and D0 has coefficient 0. Equation number 5. Equation number 5 is A0 has the coefficient 0, B0 has the coefficient 1, C0 has the coefficient 2 and D0 has the coefficient 3. A1 has the coefficient 0, B1 has the coefficient 1 and C1 has the coefficient 0 and 0 is equal to 0. Similarly, equation number 6 last. Okay, A0 has the coefficient 0, B0 has the coefficient 0, C0 has the coefficient -2 and D0 has the coefficient 6. A1 has the coefficient 0 and B1 has the coefficient 0, C1 has the coefficient -2 and D1 has the coefficient 0 equals to 0. Now we come towards this. A0 0, B0 0, C0 is 2 and rest of those are 0. Similarly, last equation has A0, B0, C0, D0 and A1, B1, C1 and D1. So this is our matrix system, constructed matrix system, and you have to, if you want to solve this system, then you have to just stop this here and you will solve this matrix system in the MATLAB. This is all about the cubic splines, and I hope that you understand this lecture.